hundreds of billions of stars in our galaxy. And yet we know of only one that shines on a life-filled planet. Is Earth unique? Or are there other solar systems and planets like ours out there? Now, scientists are finding the answer. Thanks to this, the Kepler Space Telescope, the most powerful planet hunter ever built. It's making astonishing discoveries.
The sheer numbers of planets out there is really quite stupendous.
From enormous gas giants to a land where the sun never sets, to worlds that may be entirely covered in water. Kepler is even finding planets like our own.
This might be the first Earth analog around a sun-like star that's ever been found.
Scientists are beginning to wonder if those planets could be inhabited. And if so, by what?
It's fun to speculate about life. But any life is going to be subject to the laws of chemistry and physics.
Even on another planet, we can work out how biology is likely to adapt.
This is the story of how one spectacular spacecraft has brought us closer than ever to answering mankind's ultimate question. Are we alone? Alien planets revealed, right now on Nova.
Major funding for NOVA is provided by the following. The David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. And by the Corporation for Public Broadcasting. And by contributions to your PBS station from viewers like you. Thank you. Additional funding is provided by Millicent Bell through the Millicent and Eugene Bell Foundation.
22 seconds.
The most ambitious planet hunter ever built sits on a launch pad at Cape Canaveral, Florida.
T-minus 5, 4, 3, 2, engine start, 1, 0.
Over 2 decades in the making, it is about to radically alter what we know about our galaxy.
0-3. Burning out of the solids for separation.
Meet the Kepler Space Telescope. Its mission, to detect alien worlds orbiting distant stars and to discover if any of them could be a suitable home for life as we know it. Project scientist Natalie Batalla has lived with the Kepler mission from the very first moment.
To watch it launch was really quite something. This feeling that after decades of planning, it was finally happening. It was going up there. That was a tremendous moment.
Launched in 2009, this incredible optical telescope has revealed that planets are far more common than we ever imagined.
What's amazing is not just the number of planets that Kepler has found, but the types of planets.
Of the 3,500 potential planets that Kepler has spotted, some seem familiar. Huge gas giants, similar to Jupiter or Saturn. Or smaller rocky worlds that could be like Earth, Venus, Mars, or Mercury. but others are straight out of science fiction. Like Kepler 16b, which orbits a double star, just like Luke Skywalker's home planet in Star Wars. Even more bizarre is Kepler 10b. It orbits so closely to its sun that the surface is a vision of hell.
Kepler 10b is a scorched world that's got an ocean bigger than the Pacific Ocean, that it's an ocean not of water, but of molten lava. That star-facing side, as it orbits, has surface temperatures in excess of that required to melt iron. So this is a blowtorched world.
But for Kepler, these oddities are just a sideshow. Because its primary mission is to find a planet that might have the right conditions for alien life. A planet like Earth. Now, Kepler might be closing in on just such a world. The Kepler data suggests that potentially habitable planets are out there. And applying the principles of biology and evolution, scientists are even beginning to guess how ETs could have adapted to their environments.
The best speculation recognizes that there are rules to the game. Any life that we can contemplate is going to be subject to the laws of chemistry and physics.
Kepler is finding worlds that, as far as we can tell, have the right environment, the correct temperatures suitable for life as we know it.
Kepler is unique among space telescopes. Unlike the Hubble, which turned its gaze far and wide and sent back stunning images of the cosmos, Kepler is designed to stare fixedly at one small patch of sky, taking the same snapshot day in and day out for years on end. It began, as with any new telescope, with what astronomers call first light.
Kepler's first light image came down to us at NASA Ames about 24 hours after we ejected the disk cover. As it filled my computer screen, the image that came to my mind was like champagne filling a glass, with all of these stars being the little bubbles. It was very exciting. Every single tiny dot that you see is a star that is in the field of view of Kepler.
Kepler is focused on a small patch of sky near the constellation of Cygnus the Swan.
In that area of sky are 4.5 million stars in our galaxy alone.
But Kepler isn't looking for stars. It's looking for planets that orbit the stars. But that's a problem, because Kepler can't directly see planets. Planets are much smaller and dimmer than stars. They get lost in the glare. So Kepler is looking for something called a transit, which occurs when a planet passes in front of the star. As it does so, it dims the light by a fraction. That dimming is what Kepler is designed to detect. It's a principle that can be illustrated with a distant tower and a spotlight.
Okay, let's imagine that there's a moth flying around that spotlight. Could we ever hope to see the moth? No way. The moth, although it does reflect a tiny bit of the spotlight's light, it's far too feeble for us to see that.
Since the light reflected off a planet is typically 10 billion times fainter than the light emitted by its star, detecting a planet might seem impossible. But Kepler has a way around that problem.
If the moth passes in front of the bright light, a little bit of the light that was going to reach us obviously gets blocked by the moth. Then we are able to detect the moth by measuring very carefully that very subtle change in the total brightness of the spotlight.
The bigger the moth, the more light it blocks, and the more the light dims.
In exactly the same fashion, that's how we can detect small planets orbiting other stars and even measure their sizes.
That's Kepler's primary mission, to watch thousands of stars for signs of a transit. Scientists plot the brightness of each star in Kepler's view on a graph to see how it changes over time. This is an actual plot of one star over 2 weeks. Sure enough, every 3 days there's a tiny dip in brightness, revealing a planet orbiting this star once every 3 days. Just like the moth, the bigger the planet, the more light it blocks. In this plot, a huge planet transits in front of its star, causing a much larger dip. Right from the start, Kepler saw stars dimming. By June 2010, 15 months after launch, Kepler had found over 700 potential planets.
The sheer numbers of planets out there is really quite stupendous. Here you see just a small sample of them. And the planets range in size from, a half the radius of the Earth up to things that are several times larger than Jupiter.
Already, Kepler's discoveries are changing what we know about alien planets.
Kepler has revolutionized our view of planets and planetary systems in our galaxy. It turns out that any kind of planet is possible within the laws of physics and chemistry. Any planet you can conceive of can exist in any location in a planetary system.
Extrapolating from the Kepler data, some estimates put the number of planets in the universe in the trillions. But what everyone really wants to know is, do any of these planets have life? To answer that, we have to go back to the basics and ask, is the universe full of the same stuff everywhere? Are the elements needed for life as we know it commonplace? The lightest elements, hydrogen and helium, were made in the moments after the Big Bang. Other elements are made in stars, a product of nuclear fusion during the star's normal life cycle, or produced when some stars explode as supernovas, scattering these essential building blocks into space.
Every molecule in your body, every element in your body was generated sometime in the distant past by processes within stars.
Among the most common are the elements that are essential to all living things on Earth: hydrogen, oxygen, carbon, and nitrogen. Life could be anywhere or everywhere in our galaxy. But where should we look? Since planets are proving to be so abundant, Chris McKay thinks we might as well search for life that follows rules we already understand.
I know how to search for organic material. I know what the signatures that would be important are. So the search for life starts off following water, following carbon. Not because we can prove that that's the only way to do it, but because that's the only way we know how to do it.
Sifting through the Kepler data, scientists have made a deliberate decision to look for planets that resemble the one place they know can sustain life: the Earth.
We know that the Earth is habitable, indeed inhabited, and so surely there's some drive to find another Earth-like planet elsewhere in the universe.
Humanity is on a quest to find life. Kepler's objective is first to find out if planets like Earth, where we have this one example of life, if planets like that exist.
Earth, as we know, is teeming with life. Organisms have evolved to exploit every niche. From beneath the waves to the highest mountains. So what's so special about our pale blue world? For most scientists, the key feature of Earth is the presence of liquid water on its surface. Chris McKay has spent years studying the relationship between life and water.
Well, the question is, can life survive without water? Well, this is a place to find the answer to that question. This is a desert.
In this baked dry sand near the Mojave Desert in California, Chris is looking for critters that can live without water. One possible candidate are these small black patches, which are in fact alive.
It looks like a black flat rock, but in fact, it's a layer of photosynthetic microorganisms.
But Chris has discovered that although they look bone dry, they actually require water.
The microorganisms have solved the problem of the lack of water in a very ingenious way. The organisms secrete organic materials which help to hold water. They make little super sponges, and so the rare moisture that's there, they can hold it. They can hold it longer than the normal sand. These organisms have created a little tiny microhabitat in which they live.
Chris has studied organisms across the Earth. In the dry valleys of Antarctica, and in the Atacama Desert in Chile, the driest desert in the world. And everywhere, he's found life using similar survival strategies.
We have never found an organism on Earth. The driest, coldest places, and we've looked, and boy have we looked, we've never found an organism that can make do without liquid water.
So life as we know it needs liquid water. Fortunately, water is made of two of the most abundant elements in the universe, hydrogen and oxygen. We've even detected water vapor in clouds of gas in outer space. What's harder to find is a planet that could have liquid water, where the temperature is warm enough to melt ice, and yet below the point where water boils to steam.
The sun is like a fire. It provides light, and through that light, warmth. And that warmth is what keeps the planet warm enough to support liquid water. If it's too far from the sun, the water will be ice. If it's too close, the water will be steam. So it needs to be right in that zone where the water can be liquid. Sometimes we call it the Goldilocks zone. It's not too hot, it's not too cold, it's just right.
Kepler's core mission is to find Earth-sized planets in the Goldilocks zone. Remarkably, this data that shows the timing of each transit is also the key to finding out how hot a planet might be. The more frequent the planet transits, the hotter it is.
When a planet is very close to the star, it's going around quite rapidly. The period is very short. It can go around in weeks even around the central star. As the planet is further away, it takes much longer.
A planet that orbits once a week will be close to its star and very hot. A planet that orbits every 10 years will be very far away and too cold. So scientists were looking for a planet orbiting a sun-like star roughly once a year, like Earth. On May 12, 2009, just 3 days after the spacecraft started collecting data, it saw the light from the star Kepler 22 dim ever so slightly. 10 months later, it dimmed again. If it happened once more in another 10 months, it would confirm Kepler was seeing a transit. Sure enough, on December 15th, 2010, the star dimmed once more. Kepler had discovered its first planet in the habitable zone. Kepler 22b, over 600 light-years away.
Kepler 22b was the first confirmation of a planet that is at just the right temperature. So it's in the Goldilocks zone. It's orbiting a star very much like our own sun.
The researchers can use the amount of dimming to measure the size of the planet. It works out at about 2.4 times the radius of Earth. So now comes the next mystery. What kind of planet is Kepler 22b? What is it made of? The key to a planet's composition is its size. When planets form, they start off solid, made of rock and ice. If they become big enough, they're able to hold on to huge amounts of gas, hydrogen and helium the most abundant. These become the gas giants, like Jupiter and Neptune. Smaller planets like Earth are primarily rocky and can only hold on to a thin atmosphere. Kepler 22b is in the middle, bigger than all the rocky planets in our system, but smaller than the gas giants. So is it mainly gas or rock? Astronomer Jeff Marcy is attempting to find out. Tonight, he's using the Keck telescope in Hawaii, which he's operating via video link from Berkeley, California, over 2,000 miles away.
So Jeff, I just opened up and did an autofocus. We've got about 0.85 arc second seeing.
That's great. Fantastic.
And we're set up and ready to go on your first target.
Tonight we're going to be observing Kepler 22b, the planet, which is still somewhat mysterious. We don't know whether the planet is rocky like the Earth or gaseous like Jupiter and Saturn.
To answer this question, Jeff is using a very different way of detecting planets. Nicknamed the wobble method, this technique was used to find some of the first exoplanets. And it's also used to find out more about the planets discovered by Kepler.
We can detect planets around other stars even without seeing the planets by watching the star. Let's create a star. And of course, we'd like a planet orbiting that star. Now what's interesting is that the planet not only orbits the star, but the star is yanked on gravitationally by the planet. So we see the star wobble around, and we can detect this with our telescopes here on Earth.
The Keck telescope can see if a star is wobbling backwards and forwards in response to a planet we can't actually see.
But even more beautifully, we can measure the mass of the planet, because the more mass of the planet orbiting the star, the more violently that star is yanked on gravitationally.
If the telescope detects a large wobble, it means a massive planet is orbiting the star.
We're heading to the Kepler field now. So I'm going to set the exposure meter.
Jeff takes aim at Kepler 22.
That gives us Doppler shift precision of about 1.5 meters per second. So we'll be able to measure the speed of the star to within plus or minus human walking speed. Here we go. And there it is, Kepler 22. Looks beautiful.
Even with this high level of precision, Jeff fails to find a measurable wobble, which means that the planet is not extremely massive.
So far, what we can tell is that the planet is probably not purely solid. It's not a big ball of rock.
Kepler 22b could still be a gas world, a kind of mini Neptune. But there's another possibility that's even more intriguing. this planet might be unlike anything in our solar system. A water world.
We do know that as long as the planet is over 7 times the Earth's mass, it could possibly have liquid water at its surface. So Kepler-22b, despite being a relatively big planet, is still in the potentially habitable category.
From the study of other planets, all of those somewhat larger than Earth planets have lots of water and also perhaps some atmosphere. So by association, the bet is that Kepler-22b will be a rocky planet with a very dense and thick ocean.
If Jeff is right, this would be a planet completely covered in water. It's the perfect planet for a paddle. Jeff can imagine what it would be like to kayak on Kepler-22b.
If you were kayaking on Kepler-22b, you'd look overhead, you'd see a host star that would remind you of our own sun here, a yellowish star about the same size as our sun. The gravity of the planet might be a little higher, a little lower than the Earth, but not so different.
But look beneath the surface, and this ocean is unlike anything on Earth.
The ocean would be thousands of kilometers thick. There would be no ocean floor to dive down and visit because it would simply be too far away.
Kepler-22b could have all the ingredients for Earth-like life. Energy is plentiful in sunlight from the nearby star. The necessary elements, like hydrogen, oxygen, carbon, and nitrogen, are commonplace throughout the galaxy. But for life to occur, these elements would have to form into a molecule with a very special property. A molecule that can self-replicate like DNA.
Life is a chemical system capable of Darwinian evolution. We need molecules for life that contain information. We need molecules that can mutate so that that information changes and that can be inherited. I suspect that carbon is going to be the stuff of life, and there will be information-containing molecules such as DNA.
Even here on Earth, we don't know how DNA first came to exist. But even if the creation of a molecule that works like DNA is unlikely, life may have sheer numbers on its side.
It may be that only one planet in a million will give rise to life. But on the basis of Kepler, some people have suggested that there might be 10 to the 19th planets in our galaxy or in nearby galaxies. That's a very big number. And so the probability that life exists elsewhere is pretty high.
It's this emerging statistical fact that leads many scientists to be confident that extraterrestrial life does exist.
Is there life elsewhere? Well, our galaxy alone has 100 billion stars.
If DNA, or a similar self-replicating molecule, has formed on any of those planets, life could have been around for some time.
If we go back to the very oldest sedimentary rocks on our planet and look for the signature of life, it's already there. And that tells us that life arose early.
But early life was limited to simple single-celled organisms. Microbes had the Earth to themselves for billions of years before complex life evolved. It may be that microbes rule our galaxy as well.
The most probable life on other planets would be something much more similar to bacteria than to you or me.
Of course, we don't know how likely it is that complex life would evolve on an alien world.
It's still very much an open question as to whether life could get started in such a water world. But over billions of years, if the climate was stable enough, evolution will have had the chance to get beyond microbial life to forests of complex, advanced trees.
Could plants adapt to life in an endless ocean?
On a water world, the main challenge that these plants are going to face is remaining buoyant. You can't start sinking down if you want to float, perhaps by having bladders filled with gas that help you to buoy up in the water.
While scientists can speculate about life on Kepler 22b, for now there is no way to confirm that there is water on its surface. Fortunately, it isn't the only potential life-supporting planet Kepler has found. On February 28, 2012, nearly 3 years after launch, NASA announced over 1,000 potential new planets. One of these was orbiting the star KOI 2626. This potential planet is about 1.5 times the size of Earth, small enough that it's likely to be rocky. But there's a problem. It doesn't orbit a star like our Sun. It orbits a very different kind of star.
When I was a kid, I was told in school that the Sun is an average star, which is a complete lie. The Sun is not an average star. Most stars in the galaxy are much less massive and put out much less energy than the Sun, and we call these very low-mass stars M-dwarfs. Our Sun is yellow in color, very massive, very large, and compared to it, these low-mass M-dwarf stars are tiny. They're only about 10 or 20% the size, 10 or 20% the mass, and they only put out 1/1000th the amount of energy.
M-dwarf stars, also known as red dwarfs, make up over 3/4 of all stars in the universe. Because the star is so small, it's easier to spot a small planet orbiting one. Even though an Earth-sized planet covers only about 0.1% of a red dwarf, it typically dims the light by an easy-to-see 1%. Dave Charbonneau and his team have searched through the Kepler data, and they found that more than half of all such stars have planets Earth-sized or a little larger. But could a planet orbiting such a dim star be warm enough to have oceans of water and even life?
An M-type star provides much less sunlight than our star. To get the same amount of warmth, just like this dimmer fire, you have to move in closer. There's still a habitable zone. You can get close enough to the star that it's warm enough for liquid water.
KOI 2626.01 orbits its red dwarf star once every 38 days. But being so near to a star can create a strange situation. Gravity from the star pulls more strongly on the closest side of the planet. A slight drag that can cause one side to always face the star. Astronomers call this tidal locking. This alien world would have a light side on which the sun never sets, and a dark side on which the sun never rises. At first, scientists thought that this would make the planet impossible for life because it wouldn't have an atmosphere.
When we first conceived of the notion of a tidally locked planet, even in the habitable zone, the thought was, well, on the dark side, it's going to be very, very cold. So cold that the atmosphere could condense out completely. All the carbon dioxide that would normally be in the atmosphere would be present as ice, forming a giant polar cap on the dark side. Ice like this. This is a chunk of carbon dioxide.
But atmosphere expert Kevin Hang wasn't so sure. He builds computer simulations of alien atmospheres. He's a kind of interplanetary weather forecaster. Hang used what we know about the red dwarf planet to simulate the atmosphere. And this is what he came up with. A map of the whole planet laid out flat, the colors representing the predicted temperature.
What you're seeing is a temperature map near the surface. Right in the middle of the map is the point where the temperatures are expected to be the highest.
And this temperature difference between the hot side and cold side has a profound effect on the atmosphere. Here on the dark side, the air cools and sinks, spreading out around the planet. That creates a wind that blows along the surface to the hot side. Here, the air heats up and rises before returning to the cold side. So if this planet has an atmosphere, it would have a permanent planet-wide wind system. This reduces the temperature difference and keeps the atmosphere from freezing, which means that the planet might be habitable after all, with a stable atmosphere and in some places, a pleasant climate.
You probably want to live close to where the day side transitions into the night side, the so-called day-night terminator, where temperatures are between 10 and 20 degrees Celsius. So a good spot for real estate.
If there is plant life here, it would have to adapt to an endless deep red sunset. Here on Earth, most plants capture energy with chlorophyll, a green pigment adapted to harness the yellow light from our sun. But on a red dwarf planet, with its red light, an alien plant-like species might adapt to produce different pigments. Nancy Kiang is trying to work out what those alien plants could be like. One clue is to be found in the marshes of New England.
The sandy areas you might think are just dead areas with no plants, but actually there's life teeming underneath.
Living in the sand are layers of photosynthesizing bacteria.
What we see here are different kinds of bacteria that are photosynthetic. Each layer has different pigments that absorb different wavelengths of light.
The bacteria in the top layer are green. They use the same chlorophyll that plants do because they receive the full spectrum of sunlight. But many of those frequencies get absorbed, leaving the lower layers with a different color of light. So they have evolved new photosynthesizing molecules adapted to that different spectrum. Studying these different molecules allows Nancy to imagine what sort of pigments would work best on alien worlds bathed in the dim red light of a red dwarf. It leads to an intriguing suggestion.
Very likely these plants will try to absorb as much visible light as they can. So these plants, to our eye, might look black.
Black, because the plants would need to absorb as much energy as possible from the weak sun.
Plants might find the situation actually easier to contend with because the sun isn't moving through the sky. You can just point yourself like a solar panel towards the sun. But one of the other features of a tidally locked planet would be the fearsome winds blowing constantly in the same direction. So maybe a flat panel wouldn't actually end up being the optimum design, and you want to be a bit more flexible and giving to allow the wind to kind of blow through your perhaps fan-like shape.
If there are plants, could there also be alien animals on this planet? From the wide variety of creatures that exist on Earth, we know that many seemingly bizarre creatures are possible.
It's fun to speculate about what life might look like on another planet. I think it's legitimate science insofar as it tells us that there are rules to the game. Any life is going to be subject to the laws of chemistry and physics.
Based on what we know about life in our world, and from what we know about the environment on this distant planet, scientists are beginning to imagine what alien animal life might look like.
On Earth, we find filter feeders, life that filters particles or little grains of food out of the water as it wafts past them. On a planet like this, we might find a similar strategy on the land. So maybe we'd find something like land whales that aren't filtering out plankton from the sea like the whales in our oceans, but are great big static animals that try to filter out particle matter from their wind to feed off.
Even though scientists speculate about how life might survive on truly alien worlds like this, most still believe that our best hope of finding life that we might recognize lies in finding a rocky planet, a similar size to Earth, that orbits a sun more like our own. It's a challenge of astronomical proportions.
A planet as tiny as an Earth transiting across the disk of its star is going to produce a change in brightness of just 1 part per 10,000. Imagine the tallest hotel in New York City, and everybody has their light on, and one person in this hotel lowers the blinds by about 2 centimeters. That's the change in brightness that we're trying to detect from the transit of a planet as small as an Earth passing in front of a star the size of our sun.
So Kepler scientists scour the data for signs of a truly tiny dip, evidence of an Earth-like planet. And they find something promising around star KOI 701, 1,200 light-years away. The Keck telescope confirms that there are at least 3 planets orbiting the star.
The third planet out, that planet is in the habitable zone. But it's also large, like 22b. It's like Kepler 22b. It's, probably a water world.
The team was about to go public when something extraordinary happened.
So 701.03 was done. In the bag, nice ribbon tied around it, ready to go off to the publisher for publication, when we got an email from one of our team members telling us that he'd spotted what looks to be another interesting signal in the data.
What Natalie's team member had spotted at the last moment could turn out to be one of Kepler's most exciting discoveries. It looked like KOI 701 didn't just have 3 planets orbiting it. There were 4. And this new potential planet was in the right place and the right size.
We examined the data more carefully, and there is another planet that is smack in the habitable zone, and it's only a little bigger than the Earth.
It was exactly what Kepler had been searching for. A planet in the habitable zone, small enough that it could be made of water and rock, like the Earth.
And so this is something you could stand on, something that's rocky.
This might be the first truly Earth analog around a sun-like star that's ever been found.
The planet, today confirmed as Kepler 62F, is over 1,200 light-years away. Even our fastest spacecraft would take many millions of years to reach it. But this could be the most Earth-like world Kepler has found.
And that's the amazing planet that has the hairs standing up on the back of my neck.
If this planet has oceans of water and rocky land masses, then the possibilities for life here could be as numerous as they are on our own planet.
On our planet, we began with simple bacteria, and today we have a planet that has 10 million species of animals, plants, fungi, kelps, all sorts of things.
In the oceans, the environment could be surprisingly similar to that on Earth. The density and properties of water are dictated by the laws of physics, which are universal.
What we might expect is for the aquatic or the marine life to be actually pretty similar, pretty familiar to what we know on Earth. Because the main consideration is being able to move through the water as efficiently as possible. So you want to be hydrodynamic, you want to be streamlined in your shape. And a very good streamlined shape is known as fusiform, you'll be kind of bullet-shaped, just like most fish on Earth.
This ocean could be home to a complex ecosystem, with different sizes of organism filling different ecological niches. But because this planet is 40% larger than Earth, it's likely to have stronger gravity. So what might we find on land?
Animals will respond to the increased gravitational pull on a larger planet. And so they would want to have body plans which are also very strong, so with column-like legs to support their increased weight.
On Earth, all vertebrates have a maximum of 4 legs, because all animals with a backbone evolved from a fish that had 4 fleshy lobed fins. But could aliens have more legs? That's what Bill Sellers wants to find out. He usually looks at extinct species like dinosaurs by recreating their structure in a computer. The same technique can be applied to an alien body plan.
When we have an alien life form, we treat the shape of the animal as the framework of the robot. We add motors to actually drive the creature. And then the trick is that we get the computer to learn how to be the most effective driver for this particular shaped animal.
Bill is investigating how life might move in a high-gravity environment. The computer model he's using is called a genetic algorithm. First, he creates an 8-legged alien. Then, the computer generates hundreds of random movement patterns and tests them out.
This is a moving forward start. But as you can see, what happens if it gets the pattern wrong, then although it's still moving its legs, it's lost all forward velocity and actually is starting to go backwards in a very unstable way. Other examples of failures, for example, this one, what happens is the front pair of legs trip over, and then the whole thing nosedives, and because of where the weight is, the back legs are up in the air and spinning round. So again, this is a complete failure, and we wouldn't work from those.
But the computer can take the best of those random patterns and combine them to produce new variations. It echoes the process of natural selection that drives evolution.
After the evolutionary process is finished, we end up with these very stable, very efficient gaits. What the work has shown is that this 8-legged creature mechanically could cope with higher gravity.
Bill's work shows that it is mechanically plausible that this new Earth-like planet could have animals with 8 legs walking across its surface. If this planet does have complex animals, could it also have intelligent life? For astronomer Jeff Marcy, this is the ultimate question.
We really don't know. First of all, we don't know how commonly life gets kick-started. And secondly, we don't know how commonly it evolves into intelligent life.
The probability of intelligent life evolving on another planet is perhaps the greatest unanswered question. But there are hints on Earth that intelligence might be the exception, not the rule.
Sharks, like the ones we see here, have ruled the seas for 400 million years, and yet their brains are no larger than peas. How could it be that after 400 million years, sharks have not developed a higher intelligence? And of course, the answer must be that high IQ sharks compete no more successfully than the less intelligent sharks among us. And that tells us something frightening about life elsewhere in the universe. Perhaps the intelligence of which we humans are so proud is not an attribute that is strongly favored in Darwinian evolution.
If Jeff is right, human intelligence may be the result of a very unusual set of circumstances that just happened to make our ancestors develop bigger brains. But others, like Sarah Seeger, are more optimistic.
It's a tough call about whether or not there's intelligent life around any of the nearest stars. I believe there is intelligent life out there somewhere in the galaxy, and that a future generation may be able to establish contact.
While the chances of intelligent life evolving may be small, the number of places it could be is huge.
About 900 of these planet candidates are twice the Earth's radius or smaller. So what this collection of exoplanet candidates is telling us is that small planets, planets like Earth, might be common.
Based on the Kepler data, scientists estimate that at least 1 in 6 stars has an Earth-sized planet. There could be upwards of 17 billion Earth-sized planets in our galaxy alone.
Well, we are at a remarkable moment, actually. The Kepler Space Telescope has identified several thousand planets. But what's unexpected and remarkable is that we're finding planets that are a little bit larger than the Earth, that, as far as we can tell, have the correct composition, rock and water, suitable for life as we know it.
Kepler has shown us how commonplace planets outside our solar system are, suggesting our galaxy may have other places suitable for life. Kepler continued to collect data until May 2013, when the guidance system failed, and it lost its steady lock on the stars it had watched so keenly. But the hunt for alien planets is far from over. Kepler may have a second life, using pressure from sunlight to keep it oriented. And in coming years, new planet hunters will take up the quest, exploring the age-old question, are we alone?
The exploration continues on NOVA's website. Could there be extraterrestrial life in our own solar system? Planetary scientist Carolyn Porco thinks a tiny moon of Saturn's may be the best place to look. And meet Seth Shostak, a SETI astronomer who uses radio telescopes to listen for communications from outer space. Watch original video shorts, explore in-depth reporting, and dive into interactives. Find us at pbs.org/nova. Follow us on Facebook and Twitter.
This NOVA program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. NOVA is also available for download on iTunes.